Google controls the operating system on over 3 billion active smartphones worldwide. But if you look at the premium laptop sitting on your desk right now, the chances of it running Google software are incredibly slim. Looking at this image of a typical elementary school classroom, you see Google's real computing foothold. Chrome OS is a massive success, but it serves almost exclusively as a budget-friendly, web-based platform for education. Move up into the high-margin professional market, and that footprint vanishes. Apple and Microsoft hold a tight duopoly over laptops meant for serious, heavy-duty workloads. Google maintains two distinct software environments, Android for mobile devices and Chrome OS for low-cost laptops. This split architecture makes it impossible to build the kind of seamless, premium cross-device continuity that consumers expect when paying flagship prices. To try and bridge the gap between their mobile and desktop ecosystems, Google eventually allowed Android applications to run on Chromebooks. This architectural model illustrates the core problem with that approach. Because Chrome OS is built on a standard Linux environment, the only way to run a native Android app is to trap it inside a heavy virtualization layer known as ArcVM. Running an operating system inside an operating system requires immense resources. The virtual machine aggressively consumes system memory, drains battery life, and struggles to translate basic code commands intended for entirely different processors. For the end user, this setup results in erratic hardware behavior. Audio streams drop, driver communication stalls, and basic peripherals like Bluetooth mice and headphones struggle to maintain a reliable connection. A virtualized environment imposes a hard performance ceiling. A laptop carrying the processing overhead of a virtual machine simply cannot match the highly tuned hardware and software integration found in an Apple MacBook. Google is currently executing an initiative internally codenamed Project Aluminium. It is a complete structural teardown and rebuild of their approach to laptop computing. Rather than running an Android virtual machine on Chrome OS, this design flips the entire software stack, grafting the Chrome desktop directly onto a native Android foundation. Bypassing virtualization allows bare metal hardware interaction, reclaiming CPU and memory lost to translation delays. It unifies Google's engineering efforts. A single hardware driver written for a Qualcomm or Intel processor can now deploy across a smartphone, a tablet, and a high-end laptop without modification. By stripping away the heavy virtualization overhead, Google has established the necessary foundation to run a highly responsive, professional-grade personal computer. Looking at this leaked UI mockup, the interface intentionally abandons standard mobile design. It adopts a desktop-first layout, featuring a top-left clock, a top-right status tray, and a taller, centered application dock. The operating system utilizes adaptive windowing, meaning native Android applications behave exactly like traditional PC software. They can be freely layered, resized, and snapped to specific zones on the screen. The platform also features a fully functional desktop class version of the Chrome browser, running natively on the Android framework, which includes complete support for third-party web extensions. Deeper in the system, Google integrated its Gemini Nano large language model via a service called AI Core. This enables the laptop to process complex AI tasks locally on the device, ensuring user privacy without requiring constant cloud connectivity or draining the battery. These features demonstrate a viable execution of a difficult concept. The interface effectively conceals the mobile architecture underneath a rigid, highly capable desktop workflow. The current version of Chrome OS will continue to exist. Its highly restrictive, browser-first architecture remains highly effective for secure enterprise environments and mass education deployments. Project Aluminium is a premium consumer track, launching alongside high-end ARM processors to directly challenge the MacBook Air. Unifying the underlying operating system finally enables true cross-device continuity. Users can seamlessly bounce an active workflow, like an ongoing email or a heavy web research session, straight from their phone to their laptop. Google's strategy relies on volume. They are leveraging an active base of billions of Android mobile users to provide an instant, familiar market for their new premium hardware. However, utilizing an open-source Android foundation introduces a major vulnerability into the ecosystem: manufacturer fragmentation. If hardware partners are permitted to heavily modify or skin the desktop interface, similar to how they customize mobile phones, it threatens to shatter the unified user experience and severely delay critical security patches. Allowing third-party modifications would rapidly erase the extreme simplicity, consistency, and reliability that made Chromebooks so appealing to buyers in the first place. Project Aluminium serves as a major indicator of where personal computing is heading. The mobile architecture we carry in our pockets has finally matured enough to consume and replace the traditional desktop computer.